Good day everyone, my name is Marlou Dioneda, but you can call me Kuya Marlou. I am a second year mechanical technology student from Sorsogon State University, and for today's video I will explain to you what are the gear parts and terminology and nomenclature. Okay, let's start from what is gear. A gear is a toothed wheel that transmits power, changes speeds, or changes direction in a machine. Gear are used in many machines, including cars, bicycles, clocks, and etc. Gears are wheels with toothed edges that rotate on axle. The wheel or gear will rotate around the axle or shaft. The teeth of one gear fit into the teeth of another gear. This lets one gear turns the other, meaning one axle or shaft can be used to turn another shaft. How gear works. Gears are circular discs with teeth that mesh with other gears or a chain. When two gears mesh, they rotate in opposite directions. The design of gears can be modified to create a mechanical advantage. Two or more gears working together are called transmissions. How gear works in bicycles. A bike gear system works by allowing the chain to move between different size sprockets on the rear wheel, called cassettes. Using other rear gear, which is controlled by shifters on the handlebars, this changes the gear ratio, making pedaling easier to harder depending on the terrain, allowing you to maintain a comfortable pedaling speed regardless of whether you're going uphill or downhill. This image is an example of a gear. Types of gears. Gears can be classified by shape such as an involute, cycloidal, and trochoidal. Gears can also be classified by shaft position such as parallel shaft, intersecting shaft, and non-parallel and non-intersecting shaft. There are different kinds of gear, and these are spar gear, worm gear, helical gear, bevel gear, spiral bevel gear, and etc. Examples of gears in machines. Gears are used in bicycles to transmit power from end of the bicycle to the other. Gears are used in cars to transmit power. Gears are used in clocks to transmit power. History of gears. The use of gears appears in ancient Greece in the writing of Archimedes. Archimedes is a Greek mathematician and physicist. Archimedes of Syracuse was an ancient Greek mathematician, physicist, an engineer and astronomer, and also an inventor of the ancient city of Syracuse in Sicily. Although few details of his life are known, he is considered one of the leading scientists in classical antiquity. Parts of gear. This image shows the parts of gear. There are many parts of gear. The first is the imaginary circle that represents the rolling action of a tooth gear is called the pitch circle. The point where two pitch circles meet is called the pitch point. The height of a tooth above the pitch circle is called addendum. The distance a tooth extends below the pitch circle is called dedendum. Circular pitch is the distance between corresponding points on the adjacent teeth. Diametral pitch is another way to specify the size of a gear. Pinion is the smaller of two mating gears. Gear is the larger of two mating gears. Relationships between gears. Line of action. It is the path of contact between the teeth of two mating gears. Pressure angle. It is the angle between the line of action and a tangent to the pitch point. Tooth thickness. The thickness of a gear tooth measured along the pitch circle. Nomenclature. What is nomenclature? Gear nomenclature is the terminology used to describe the construction and function of a gears. It includes the terms for the various parts of gear, as well as the relationship between gears. I have attached one example of a gear nomenclature, and this is the helical gear nomenclature. The nomenclature of a helical gear has a helix angle. It is an angle between a tangent to the helix gear and the gear axis. It is zero in the limiting case of a spur gear, albeit it can be considered as hypotenuse angle as well. Normal circular pitch point to circular pitch in the plane normal to the tip. Transverse circular pitch point to circular pitch in the plane of rotation of the gear. Sometimes it's called circular pitch, such that P is equals to P cosine. Several other helix parameters can be viewed either in the normal or transverse planes. The subscript N usually indicates the normal. Worm gear nomenclature lead the distance from any point on the thread to the corresponding point on the next turn of the same thread, measured parallel to the axis. Linear pitch is the distance from any point on a thread to the corresponding point on the adjacent thread, measured parallel to the axis. For single thread worm, lead and linear pitch are the same. Lead angle is the angle between a tangent to the helix and a plane perpendicular to the axis. Note that it is the complement of the helix angle between usually given for helical gears. Pitch diameter is the same as the described earlier in the list. Note that for a worm, it is still measured in a plane perpendicular to the gear axis, not a title plane. And that's all for today's video. I hope that this video presentations helps you. Thank you for listening. Once again, this is Kuya Marlou. Bye bye.